Hi everyone, welcome to the talk. My name is Simbo. I am software engineer working at Amazon Elasticache. Today I'm going to talk about how to mitigate connection storm to keep your Redis cluster highly available. For anyone who is not familiar with Amazon Elasticache, it provides managed Redis solution. You can easily deploy, scale, and back up your Redis cluster. In this talk, we are going to talk about what is a connection storm, and then we will cover how to detect, mitigate, and prevent a connection storm. To start, I will talk about a real customer case to explain what is a connection storm. A couple years ago, there's a customer running video sharing service. They use Redis Cluster to cache video segment. The segment is around 100 kilobytes. The Redis cluster is very heavily loaded. CPU utilization is around 100%. The client was configured with low timeout and retry immediately after request timeout. Everything works pretty well until all of a sudden there is an outage. Request rate dropped to the floor and new connection rate skyrocketed. This outage lasted for half an hour until customer shifted traffic away. Customer is very upset and engaged us to root cause. Specifically, they want to figure out two things. One, what triggered this outage? And two, why this outage lasts so long? After diving deep into the cluster, we found two things. First, using slow log, we found there is a slow command happening at the beginning of the outage. This slow command lasts for a few seconds, which is way longer than request timeout. As Redis is a single-thread engine, this caused all concurrent requests are timeout. This revealed the trigger of the outage. Second, another symptom is Redis server spent majority of its CPU time on accepting new connections, leaving much less time on processing customer requests. This is quite unusual. On a healthy Redis cluster, it spent majority of its time on processing requests, while only a fraction of its CPU time on accepting new connections. But during this outage, this reversed. This symptom helped us to figure out why the outage lasts so long. And it turns out it is caused by connection storm. So at the beginning of this outage, lots of requests are timeout. Clients immediately start to retry these requests. This generates a massive amount of new connections. This caused Redis server to spend lots of time on accepting these new connections, which left much less time on Redis server to handling real customer requests. This caused more request timeout, and more request timeout cause more retry from clients, which generate more new connections. This vicious cycle goes on and on until customers shifted traffic away. And this vicious cycle is connection storm. Now we explained what is the connection storm. Let's see how to detect a connection storm. The most intuitive way is to use new connection rate to detect connection storm. However, Redis engine is very fast. It could process hundreds of new connections per second. Therefore, monitoring new connection rate is going to cause a lot of false positive. By diving deep into TCP connection establishment, we figure out another way to detect the connection storm. So on the right, we have client and Redis server. Redis server runs operating system and Redis process. After three-way handshake, client establish a TCP connection with the operating system first. The operating system placed the established connection to a bounded queue. And Redis process will pull the new connection from the queue and continue the connection establishment. During the connection storm, as there are so many new connections, Redis process could not pull new connection fast enough from the queue. This causes queue overflow. And once the queue overflow, new connections are dropped. We can monitor the rate of dropped new connections to detect connection storm. So now let's see how to mitigate a connection storm. As we mentioned, the connection storm vicious cycle. If we can break the cycle, then we can stop the connection storm. So the easiest way is to throttle the number of new connections on Redis server side. And once server spend less time on processing new connections, it will have more time on processing customer requests. This will allow more requests to be served within timeout, so that clients retry less number of requests and generate less number of new connections. This mitigation is available on Amazon Elasticache. And here is an example of using IP table rules to throttle new connections. These two rules combined will throttle the number of new connections to 100 per second. Now let's see how to prevent a connection storm. There are two ways. First, always use connection pooling if that's possible. Connection pooling prevents clients to open new connections for every single new request. This allows Redis server to have more time processing requests, reducing the chance entering into connection storm. And second, using exponential backoff retry policy on your client. This prevents your client generate massive amount of new connections after request failure. To wrap up this talk, here are a few takeaways. First, connection storms cause Redis service outage, and the outage could last for a long time until traffic gets shifted away. Second, always try to configure your client with connection pooling and exponential backoff retry. And very last, use managed service to get connection storm protection from server side. Thank you very much. This is the end of talk. Hope you enjoy it.